some of the cool tech that we found at this year's CES. If I'm honest, I have to say, this is the coolest, isn't it? This is the gigantic Mondo Spider. It's made by an art outfit based in Vancouver. And one of the purposes, apart from looking just stupidly cool, is to raise awareness of sustainable energy, because it's actually powered by lithium-ion batteries. And that's only been possible in the last few years as the battery technology has got small enough and light enough to put into your average giant robotic spider. It weighs about 750 kilos. The turning circle, well, is acceptable if you ask me. And you drive it like a tank. You've got two control knobs here, one for the right side and one for the left, and you just pull them backwards, push them forwards. You know, I mean, everyone's done it, haven't they? This is the Spaceflight Operations Facility, and this is where they process all the signals that are being received from the various NASA missions that are up in space. For example, the yellow text over there, that is the data that's being received from the Curiosity rover on Mars. Now, I don't know about you, but it came as a surprise to me to learn that the way they control these robots and spacecraft is generally by typing lines of code. But that is starting to change, and here at JPL they're working on new ways of interfacing with their robots. Mark Chislak has been taking a look.
If I want to actually go to space in a few years' time, if I win the lottery, outfits like Virgin Galactic might be able to make that possible. But if I want to set foot on extraterrestrial soil, ground, or whatever, that's probably never going to happen. But the engineers at the Ops Lab have got the next best thing. By combining real data and images taken by the Curiosity Mars rover with the Oculus Rift virtual reality headset, the team at JPL can virtually transport whoever's wearing the headset to the surface of Mars. An addition that's been made to the headset are these silver balls on stalks. The team's also built a Vicon motion tracking rig in the lab. The cameras in the rig monitor the position of those silvery orbs. Because of the mocap rig that there is on the top of this Oculus headset, I can actually walk around. I'm not stuck to one spot. Allowing me not just to see, but to walk on another planet.
We focus on current and future missions about how to operate and control robotics and spacecraft better. There's a lot of benefits in using these tools that are already in the public. The scientists and engineers that we give them to, they have these technologies at home and they're comfortable using them. Also, these companies have spent millions of dollars and hundreds and thousands of hours making sure these technologies already work well in the home, in the workplace, and in harsh environments.
The Ops Lab engineers are pretty adept at combining off-the-shelf kit with their own software. Here, the VR headset combines with an Xbox Kinect motion sensor and a camera. All of this kit is connected to a robot arm. The motion sensor reacts to my arm movements, and the robotic appendage copies them. The headset allows me to see the robot arm's movements as if it were attached to my own body. That's a pretty good feeling. I can manipulate a robot arm to pick up Lego. Hang on, let me see it with my real eyes. You're strangely disconnected from the real world with the Oculus goggles on. Equipment like this could be used for repairing spacecraft, with a robot exposed to the vacuum of space and an astronaut safe inside the ship effecting repairs via virtual reality.
Mark Chislak getting virtually hands-on with some very cool tech indeed.
The Jet Propulsion Lab isn't just concerned with research. The engineers and scientists based here are in control of 19 active spacecraft, including 3 rovers. And you yourself can get some idea of the scope of NASA's missions by visiting eyes.nasa.gov, which allows you to explore all of its satellites, probes and mission data, or you can simply take a joyride around the universe.
Time now to head from
compared to what's in the garage down the road. This is Athlete.
So Athlete is the all-terrain, hex-limbed extraterrestrial explorer. The idea is that this is a cargo hauling robot that won't get stuck on the lunar surface, which basically means we want to go off-roading, off-planet.
It's a prototype, but could one day be hauling everything from drilling equipment to homes across alien terrain.
This is the prototype Athlete, or to be more accurate, half the prototype, because the other 3 legs would go over here, and in between those 2 halves goes this, the cargo pad. This is where you put the stuff that you want to lift up and move about.
Curiosity seems a bit fragile in comparison. Athlete is designed for heavy-duty work, watching out for obstacles from every angle. This thing will follow its daily instructions and can autonomously make its own decisions to avoid things that get in the way. And the coolest thing of all is the way it gets itself out of trouble.
So Athlete has small wheels on the end of 6 fully articulated robotic limbs, and that means we can roll across easy terrain, and if we get stuck, we can just walk out of it or walk over it.
And those wheels wouldn't be fitted with inflatable tyres. No, they would be space wheels. Light, rugged, and of course not liable to puncture or burst in low-pressure environments. And although this version weighs 2 tons, the Athlete design is scalable. It can be built a lot smaller, or it could be twice as big. Imagine that crawling across the lunar surface towards you.
I know it's happening quite slow, but still quite weird and a bit intimidating.
For now, Athlete is still earthbound, but it is a reminder of just how much heavy lifting robots have already done across the solar system.
Welcome. The time is 6:47 a.m. There are pick requests available.
Begin.
Incoming pick request. For customer 351, 22 items. Please confirm.
Confirmed.
Showing me the pick list. Go to aisle 17, shelf 3.
Show item 1.
The size for item 1 is 30 by 25 by 5 and a weight of 0.5 kilogram. It's non-fragile. Pick 2.
Okay. 1 okay.
Pick request confirmed.
Pick 3.
Okay.
Order complete. Warning, forklift malfunction detected. Proceed to maintenance area.
Okay.
Hey, how are you doing? Be sure to set it to DC. What's the voltage?
Okay. Reading 12.3, 11.9.
Just put both tubes together and you should be fine.
Warning! Forklift nearby. Order complete.
Pause.